All right. Hello and welcome to week number 16. This is the last week of new material. Okay. So this week, and I think you guys are going to have an easy time with this week's material. So next week, what we're going to do is we have a practice or a review for the semester exam, just like last semester. So week 17 is a review for the semester exam. Week 18 is the semester exam. Now, I did open both of them today. So let's say you did today's homework and you thought it was super simple and you got it done already. And then it's like, oh, I'm gonna go and do the week 17 practice. You do not have to do the practice 17 to get access to the exam. Okay, you do not have to do week 17. However, I will put this out there. Um, you only get one chance at the semester exam. Okay, so if you do poorly on the semester exam and you email me and say, Mr. Shanklin, I want to redo that, the answer is going to be no. Okay, I know, I mean, that's not a problem. I get that all the time. Week 17, the practice for the exam looks exactly like the exam, just like it did last semester. What I did when I made the exam out, I did the practice. So there's 10 questions on the practice, there's 10 questions on the exam. So that's how it's done. Now, do you have to do the week 17 practice? No, you do not. Next week, during the main lesson, we are going to go through all of the practice problems for week 17. Do you have to come and watch? Absolutely not. If you decide that you understand the material and you're going to take the exam, more power to you. You can be done this week if you wanted to. I'm not going to stop you from doing that. Okay? Now, please don't email me and say, Mr. Shanklin, I finished all my stuff. Can you figure out my semester grade? I will not do that. Okay? And the reason is, in the next 2 weeks, I am going to be getting hundreds of assessments to correct because some people procrastinate a little bit and they'll be turning everything in the last couple weeks. So I can't keep going back and updating people's semester or grades. So that won't happen. Now, you obviously can look at what you've done and see how you did. Now, the semester exam is going to count as an assessment. It's going to count as the last assessment for each learning target. There's 3 learning targets in this class, so there's 3 parts to the exam. Each part will go to, like, the first part of the exam will go to target number 1. The second part of the exam goes to target number 2. So, saying that, if you guys are paying attention, how many problems are on the exam? 30. That's exactly right. There's 30. How many multiple choice questions are they? 30, right. They're all multiple choice. So, taking that in consideration, how many problems are on the week 17 practice? 30. Do you have to get an 80% or better to get to the exam? No, you don't. You do not have to do week 17 if you didn't want to. I encourage that you do it. Yeah, you don't even need to get a 0%. I encourage that you do week 17 just so you have an idea, because do you guys remember what we did the first week of this semester? Early, yeah, we started off with trigonometry, started off with the unit circle, then we went into special triangles, 30, 60, 90, 45, 45, 90. We did radian measure, degree measure. We did logs and exponents. Yeah, so we did a lot of stuff this semester. That's why it's probably wise to take a look at week 17 so you know, because if it's not on week 17 practice, it won't be on the exam. Okay, I'll just make that clear to you guys. I did it exactly like I did last semester. The practice looks exactly like the exam. Okay, enough yapping for me. All right. Uh-oh, I did not. Oh, darn it. I yapped too much in the beginning and I didn't get the Desmos presentation for you guys ready. So let me get this. Hopefully this week our presentation matches with because last week, remember, it didn't match. That was not cool. So hopefully this week it will match. Okay, so this week we are going to deal with independent and dependent events, probability. I think you guys are going to have a really easy time this week. However, one student did talk me into changing my answer key. And then this morning I'm looking at the problem. It's like, that is not correct. So I changed it back. Independent events. Two events are independent when the occurrence of one has no effect on the occurrence of the other. For instance, rolling a total of 12 with two six-sided dice has no effect on the outcome of future rolls of the dice. So independent probability, you just find it by multiplying the probability of one event times the probability of the second event. Okay, exactly. If you have some weird dice. So independent means that one event does not affect what happens on the second one, and we'll go through that a little bit more in just a bit. So here's the probability of independent events. A coin is tossed and a six-sided die is rolled. So if the coin ends up on a head, that doesn't mean that the die is going to end up on a six. These are two independent things. The coin and the die do not affect each other. That's what it means by independent. So if I wanted to find out the probability of getting a coin and a six on a dice, well, probability of getting a head is 1/2. Probability of getting a six is 1/6. Multiply that together, I end up with 1/12. Okay, so that's how you find the probability of independent events. Now, dependent events, a little bit trickier. Okay. Oh, don't I have a slide on dependent? Okay, there's dependent. Okay, so here, let's say that we have a jar of marbles containing 4 blue marbles, 5 red marbles, 1 green marble, and 2 black marbles. A marble is chosen at random from the jar after replacing it. So you're going to pick the marble, you're going to pick one marble out, you're going to put it back in. So the second draw does not, so whatever you choose on the does not one, right? Because you've put it back in. And that's why it's independent. So in this problem, it says, find the probability for the following. Probability of a green and red. So the probability of a green marble, if I did this problem, what do we have? 12 marbles. So that's going to be 1 out of 12 to pick green. And then red would be 5 out of 12. And then we would just multiply that across. That would give me 5 out of 144. Is that? So the probability of getting a green and a red would be 5 over 144. So independent events means that the first does not affect the second. So now let me try to explain dependent events. Dependent events means that the first outcome does affect the second outcome. Okay? It absolutely does. For example, let's say I have a deck of cards. Okay? How many cards are in a deck? 52. How many kings are there? How many kings are in a deck? 4. One of each suit. Good. So let's say I asked you to find the probability of drawing a king, then a king, without replacement. So I'm going to draw a card, then I'm going to draw another card. What is the probability of getting 2 kings in a row in a deck of cards? Okay. 4 out of 52 times 3 out of 51. That's absolutely correct, because the first king, there's 4 kings out of 52 cards, right? But now 1 card is gone. That's why this is dependent probability, because what you get on the first draw does affect the second draw. So now on the second draw, there are only 3 kings left, and there's only 51 cards left. So now if I multiply across, I would come up with the probability of getting 2 kings in a row. Yep. Kids struggle. They don't realize that you're not putting that, they'll put 4 out of 52 and then they'll go 3 out of 52. It's like, there's not 52 cards left. There's only 51. So now let's go back to that bag of marbles. Oops. I guess we'll do another card one. 2 cards have been drawn from a deck of 52 cards without replacing the first one. back. Find the probability of getting first card as a king and the second card as a queen. Okay? So, what is the probability of getting a king on the first draw? So 4 out of 52 times 4 out of 51. Very good. It's absolutely correct. So getting a king on the first draw, 4 of them out of 52 cards. Getting a queen on the second card, well, there's 4 queens still in the deck, but there's only 51 cards left. And then I would just multiply that across. Now, I would simplify first, right? Because who wants to multiply that out? So I'd simplify before I would multiply. All right, now, find the problem. Now, do I not have marbles for this one? I don't. Darn it. Okay, I'm going to go backwards. Okay, so I'm going to use these marbles. But I'm going to say that we're going to, because there's a problem just like this on the test. And some kids really, they mess with my head sometimes, okay? I am outside. You guys can probably hear the birds singing in the background. All right. So let's say I'm going to give you 2 problems here. Problem number 1. Yeah, it's getting a little breezier, but not too bad. What is the probability of getting a blue, then a blue without replacement? And then problem number 2, what's the probability of getting a red, then a green? Okay. So now this is where it's really funny. I've had this happen to me a couple of times. So what is the probability of getting a blue on the first draw here? 4 out of 12. And then what's the probability of getting a blue on the second draw? So one of these blues is gone, right? Gone. 3 out of 11. All right. So then I would reduce this down. You know, that would be 1 out of 3, and then the 3 would cross off, so I'd end up with 1/11. Okay. That would be my answer. Now, so now you've drawn 2 blues out. I've had kids do this, and then on problem number 2, they don't. This is a whole nother problem, okay? So you start with the same bag of marbles. You start with the same 12 marbles. So I've had kids where I've done this problem, and I ask like 6 or 7 questions, and I have a student email me and say, Mr. Shanklin, there's no marbles left in the bag, the 4th one. It's like, no. When you go to problem number 2, you start with the same 12 marbles in the bag. All right. So in problem number 2, the probability of a red, well, there's 5 out of 12. And then a green would be 1 out of 11. Okay. So when you go to the next problem, you start with the same bag. All right. So that was kind of interesting when kids said that. It's like, there's no marbles left in the bag. Yeah, I think there is. All right. I want to go on to the practice for today, because the first problem, I want to really discuss that one. All right. So here's the Desmos presentation. Let me, oops, I don't need that anymore. I don't this anymore. Okay. So let me share my screen here. Let's see here, week number 12 or 16. There we go. Okay. So here is, I kind of went back and forth on this problem, and I kind of changed the answer key last night, and then it's like, the more I thought about it, it's like, no, that's not right. So sometimes when you're doing probability, you have to think about the sample space, okay? Sometimes you have to start thinking about the sample space and could you write it out? So for this first problem, it says, what is the probability? Holy cow, that is really small. What is the probability that 3 standard dice are rolled simultaneously? Will all, this is really worded really weird too, that they will all have the same number facing up. Okay, what is the probability of that? And I looked at that problem and I thought, okay, I could make the sample space, but I really don't want to. But I did start off by doing this. I started off and I looked at this and said, okay, same. So I could have a 1, 1, 1, a 1, 2, 1, a 1, 3, 1, blah, 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 and keep going. And then my next row, I could have 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, 6, 6, 6. Because that, it says the same number facing up. So how many ways are there? I don't have to draw out my whole sample space. I know that this is the only way that this could happen. And I don't have to draw out the whole sample space. So 1, 2, 3, 4, 5, 6. There's 6 ways that you could have all numbers being the exact same thing, that all the have the same number facing up. And that would be out of, well, remember the bottom, what is that? 6 times 6 times 6. So if I was a smart math student, I would just simplify. So that's 1 out of 36. That's how I did that problem. Because there are 6 different ways out of 200 and whatever that is, 214. But you do have to simplify it down to be 1 out of 36. So that one, just thinking about the sample space, helped me visualize what the answer would be. And remember, probability doesn't change. Probability is the number of ways something can occur over the total number of ways. Well, when you toss 3 dice, there's 6 different ways that you could get all of them being the same number on top. Okay. All right. So that one was, it's a little weird, but it does work out. Okay. Problem number 2 on this week's practice. I'm going to let you guys do this one. It says, suppose you simultaneously roll a standard die and spin a spinner that is divided into 10 equal sectors, numbered 1 to 10. What is the probability of getting a 4 on both the die and the spinner? Okay, what is... this is our last session with new material. But next week we will also have a session, but it's doing a review for the exam. But some, as I said, some kids are going to finish everything this week. You're going to finish this assignment this week in no time, and then you're going to go right on to doing the semester exam, which is perfectly fine. Okay, so you guys are saying the answer is 60. So let me read that question all over again, because I forgot what it said. Suppose you simultaneously roll a standard die and spin a spinner that is divided into 10. What is the probability of getting a 4 on both the die and the spinner? Okay, so 4 on the dice would be 1 out of 6. A 4 on a spinner would be 1 out of 10. So that's 1 out of 60. I agree 100% with you, those of you that said 1 out of 60 or letter D. You are absolutely correct. Very nice. All right. Problem number 3. Suppose you simultaneously roll a standard die and spin a spinner with 8 equal sectors, numbered 1 to 8. What is the probability of both rolling an even number and spinning an odd number? Okay, so now they're going to start making us think about what's on each one. Okay, what should my answer be there? Got to think a little bit harder on this one. Letter C, 3 6 times 4 eighths, which is 1/2 times 1/2, which is 1/4. I agree 100%. Okay, so when you think about rolling an even number, well, even numbers on a dice are 2, 4, and 6, so that's 3 out of 6. Odd numbers on the spinner, well, that would be 1, 3, 5, and 7, so that's 4 out of 8. So I really have 1/2 times 1/2, which is 1/4, or letter C. All right. Any questions up until this point? Are you guys okay with this? As I said a couple weeks ago, our last couple of weeks are pretty easy. All right. Next question. Number 4. It says a coin is flipped and a card is drawn from a standard deck of cards. What is the probability of getting both heads and a red face card? Okay, so what is the probability of getting both heads? Okay. And 1/2, and then 8 out of 52? No, 6 out of 52? All right. So on this problem, I'm looking at the coin is flipped and a card is drawn from a standard deck. What is the probability of getting both heads and a red face card? Well, a coin is flipped, a head is just going to be 1/2, right? And a standard deck of cards, what is the probability of getting both heads and a red face card? Well, how many red face cards are there? We've got jacks, queens, and kings, and there's 2 of each, right? Because there's a heart and a diamond, heart and a diamond, heart and a diamond. So there's really 6 out of 52. Okay. If I reduce, that gives me 1. That gives me a 3. So 3 out of 52. Does that reduce down? I don't think it reduces. So that looks like letter C for the answer. Three is prime, so it doesn't. I'm not sure what prime has to do with this one, right? 3 is prime. Oh, so it doesn't reduce. Okay. Yeah, but the bottom could have been a, let's say, if that was 51, that would reduce, right? It's the bottom number that's going to, yeah. It's the bottom number that's going to tell you if it simplifies or not. Because if you had 51 on the bottom, then you could have reduced that down. That would have been 1 over, I don't know what that is, 17 then, I think. And you know, if you're not good at cards, you can always go back to that slide that I had in the beginning, had all of the cards on there. Yep, you don't want to count aces. It's just jacks, queens, and kings, and there's 4 of them. But there's always just two reds and 2 blacks. That is true. I agree with that. But most of the times when they talk about playing cards, they're talking about a standard deck when they're talking probability questions. So we always have to go with that. All right, number 5. Boy, this writing is really small. A bag contains 3 green marbles, 4 black marbles. All right, so I'm gonna do my awesome artwork here. A bag contains 3 green marbles. Okay, so 3, 1, 2, 3, and 4 black marbles. 1, 2, 3, 4. Okay, so there's my bag of marbles. If you randomly pick 2 marbles from the bag at the same time, what is the probability that both marbles will be black? Now, if I was going to do this problem, I would go probability, black, and black. So the probability of the first one being black is 4 out of 7. And then the second draw, you don't have 4 marbles. You don't have 4 black marbles left. You only have 3 out of 6. So I would do 4 7s times 1/2, which is, again, I'm just simplifying before I do anything. 2 7s? Does that make sense? Okay. Because when they say at the same time, you have to realize that that is a dependent or a dependent event, because whatever you grab first, you know, you can't grab them both at the same time. So your probability should be 2 7s there. All right. Problem number 6. What is the probability of rolling a total of 7 in 2 rolls of a standard die if you get an even number on the first roll? Yikes. This one, I probably would make the sample space out, to tell you the truth. Because I'm looking at this and it's like, okay, first one is even, so I'm gonna roll 2 die. So I've got 1 1 1 2 1 3 1 4, and it doesn't take too long to make the sample space out. 2 1 2 2 2 3 2 4 2 5 2 6 3 1 3 2 3 3 3 4 3 5 3 6 4 1 4 2 4 3 4 4 4 5 4 6 5 1 5 2 5 3 5 4 5 5. And now some of you might not have to do this, and more power to you. I just, sometimes, just doing a sample space in my mind so I can see what's happening is a good thing. And it says, what is the probability of rolling a total of 7 in 2 rolls? Okay, so first thing I'm going to do is I'm going to just circle all the ones that add up to 7. So 7, 7, 7, 7, 7, 7. So those are the only ones. However, it does have another stipulation. If you get an even number on the first roll. Okay, so now, no, I got an even number on the first roll here, so I'm going to keep that one. No, even number on the first roll here, so I'm going to keep one. No, even number on the first roll here. So 1, 2, 3 out of 36. Now I can't read that. I don't think that says that. So if I reduce it 1 over 12, so letter A, and doing weight no doubles, well, add up to 7. So you can't have a double in there. But so that sample space really helped me visualize what was going on in this problem. And sometimes I think that's the easiest way of doing it, is just to make a sample space out and then look at it and it's like, oh, okay, so the first one adds up to 7, so these are the only ones that add up to 7. However, it said that the first roll is an even number. Okay, so those, the 6 1, the 4 3, and the 2 5 are the only ones that would be an even number first. Any questions on that one? As I said, sometimes just making a sample space really helps out a lot. All right, let's go on to the next problem. Number 7, it says if you have 8 pairs of socks in the dryer, only 1 pair is black, you randomly choose 2 of the socks, what is the probability that you got both of the black socks? Okay, that's an awesome problem. All right, so you guys figure that one out and see what you get for an answer. And I'll let you guys just listen to those birds singing away as you answer your questions. 2 8 times 1 7. I disagree with that. And the reason I disagree with that is, remember, a pair of socks is 2. So how many socks do you have in the dryer? Or was it in a wash machine? You have 16 socks in the wash machine. So Angela, I would agree with you that 2 out of 16 times 1 out of 15 is going to be the correct work on that problem. Because when you think about it, there's 16 socks in the dryer, so the probability of getting a black on the first one is 2 out of 16, and then I only have 1 black sock left, and I only have 15 left. So I'm going to simplify that down, 1 8. So 1 out of 15 times 8, what is that, 120? So the probability that you get both black socks, it's not very good, is it? It should be letter A. for that one. Okay. Not a very good probability that you're going to get both black sides. All right. Next question. 2 coins and a numbered cube are tossed at the same time. What is the approximate probability that the coins show different sides and the numbered cube shows a 1 or a 6? Okay. Now, when I did this one, I thought about what is the approximate probability that the coins show different sides? Well, if I toss 2 coins, I could get a head, 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 tail, tail, head, tail, tail. That's the only 4 different ways you can get. So what is the approximate probability that the coins show different sides? Okay, so there's 2 of them. So that's 2 out of 4. Times a 1 or a 6, well, that's 2 out of 6, isn't it? Then I'm going to reduce 1/2 times 1/3. I get 1/6. Well, they gave me all the answers in decimals, so I divided this. I think I get 0.16666 all the way down. So I believe 0.17 should be the correct answer, or letter A. Okay, does that make sense? Again, a lot of times, I don't remember what number are we on right now. I don't even remember. I don't even know what number this is. I don't have them numbered at the top. This is number 8? Okay. So if this is number 8, number 7 would be this one, which is 1 over, so that would be A also. Yes. So number 9. It says you randomly choose one of the chips without replacing the first chip. You choose the second chip. Find the probability. And then it says white and not green. Okay, so the probability that we get a white on the first draw, so that's how many chips are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1 out of 10 for white, not green. So that means everything this one's gone, remember? That's gone. So 1, 2, 3, 4, 5, 6, 7 out of 9 would be not green. Doesn't look like there's much to simplify in this one. So 7 out of 90? Is that correct? Uh-oh. We don't have any answers there. What the heck happened? Is anybody on that assessment? What is 7 out of 90? Is that letter B? Okay, thank you. Thank you. All right, so that should be B for those. Okay, I don't know why I don't have the answer key down there. Sorry about that. Did not mean to do that. All right. That is the last question. There are 3 red, 1 blue, 2 yellow marbles in a bag. Once a marble is selected, it is not replaced. Find the probability, red, then yellow. Okay, so how many marbles do we have? 3, 1, 2. So we have 6 marbles. So red. So they want probability of red. Well, that's 3 out of 6. I don't replace it. And then a yellow. Well, there's 2 yellows, but there's only 5 marbles left in the bag. So I've got 1/2 times 2/5. Simplify. I always simplify. Makes it a lot easier. Don't have to multiply as much. So letter B, or 1/5, is the correct answer. That is the last practice problem for this week. Next week, we have exam review. Do you have to do the exam review to do the exam? No, you do not. I encourage students to come so they understand what's going to be on the exam, but I understand some of you are going to want to get all of this stuff done. You want to be done with algebra, boom, that's fine. Go ahead. Do the practice, do the exam, you'll be done for the year. You don't get another shot no matter what, Samantha. The exam is set up to be taken only once. Even if you do the practice, you only get one shot at the exam. So that is absolutely correct. The practice could be like taking the first shot at it. That is true. But yes, the exam is only set up to take one time. So please, when you do take the exam, make sure you have enough rest in you so you do your very best. And it counts the same as any other assessment. It just happens to be the last assessment for each target. So I will look at it a little bit more heavily than I do the other assessments. But, if you had all advances, this one, is approaching on the exam, you're still going to get advanced. It is multiple choice, correct? Yes. Yeah. There's 3 targets this semester, just like last semester. There are 10 questions on each one, so there is a total of 30. There'll be a total of 30 questions on your exam. I don't get question 7 on 16B. I can't help you with that because this is I can't. Let me just go check 16B out. But I can't give you an answer on it. Let's see here. This is week 16, 16B. That would be the multiple choice ones, right? All right. Number 7. Oh, that's a tree diagram. A large company rates its employees every 6 months. This must have been from last year when we were doing. Just put A down, please. Just put A, and you will get it right. Sorry about that. That problem shouldn't have been on there. And I would delete it. However, as soon as one person takes the test, you can't. It's kind of closed off to the teacher to making any changes to it. So I could not delete that problem if I wanted to. So just put A down, and you will get it correct. All right. Uh, 16B, the B assessment, number 7. That's question number 7 on 16B. Yep. Put down A. All right. You guys have a great week. Get outside. It's beautiful today. The sun is shining. The birds are singing.